we're going to look at polynomial inequalities. Okay? So we're still going to put our zeros on the number line. And the rule is still the same, right? Open circle for less than or greater than, closed circle for less than or equal to, and greater than or equal to. Now here we're going to have two options. I have just one written there, but we're going to have two options after that. The first is going to be to test a number in each interval to see if the graph is positive or negative there, okay? And we're going to do that. The other option is to use, let me see, how do I want to say it? Use the polynomial shape. And multiplicities. Multiplicities. There's a lot of I's in that word. And I'll tell you what I mean. Okay, so this is different from a quadratic because a quadratic only has two factors, right? So now we have more than two factors. So we have x plus 2, x minus 4, x plus 6 is less than 0. So just like we've been doing, we're going to pull our zeros out. So x is either a negative 2, a positive 4, and a negative 6, correct? It's just like we set that equal to 0 and pull them out. So those three guys are going to go on my number line. I have a negative 6, a negative 2, and a positive 4. Will my circles be open or closed? Open. So I'm open at all of these. So far, so good? Okay. So next, we need to know in each of those intervals, each place between our circles, is the graph above or below? Okay, so the first option, that test a number in each interval, let's do that. So I'm going to start looking at the left of negative 6. Something less than negative 6, I'm going to say, what if x is negative 10? I could have picked negative 1,000,000. It doesn't matter, okay? So now I'm going to plug that negative 10 in for x for each of those factors, but I only want the sign, S-I-G-N, of the answer. Is it positive or negative? Because in the end, I'm not interested right now in the actual value at negative 10. I just want to know if it's above the x-axis or below the x-axis. So negative 10 plus 2 gives me a negative number, right? Negative 10 minus 4 gives me a negative number, and negative 10 plus 6 gives me a negative number. And negative times negative is positive, times negative is negative. So the graph is below the x-axis until it gets to negative 6. Between negative 6 and 2, and negative 2, let's pick a number. How about x is negative 4? Yep, I'm looking for something in the middle there because I just want to know, okay, we actually, well, we'll talk about that in a second because we actually already know this, but I'm going to keep going here. So at negative 4 plus 2 gives me a negative number. Negative 4 minus 4 gives me a negative number. But negative 4 plus 6 gives me a positive number. So, between negative 6 and negative 2, my graph is positive. Negative 4 minus 4 is negative 8. All right, let's go from negative 2 to 4. Let's see what happens at x equals 0. Always easiest to use a 0 if you can, right? So I'm going to have a positive. 0 minus 4 is negative. 0 plus 6 is positive. So that means the graph is negative between negative 2 and 4. And then to the right of 4, we'll just do 5. When I plug in, 5 plus 2 is positive, 5 minus 4 is positive, and 5 plus 6 is positive. So the graph is positive from there. So that means that the graph must start down, go through here, come back down, and go back up, right? Which, honestly, we already knew because that's a cubic, right? It would be an x cubed, right? That goes down to up. And each of those factors has a single multiplicity, so it crosses each time. Okay, so that's kind of the other option, is to realize that and just draw it. Okay, so we're not quite done yet because they want the answer as an interval or a union of intervals. Well, we want less than, so we want everywhere it's negative, right? So we have the piece on the left and this piece. So we want to write that in interval notation. So the smallest number we can use is negative infinity, right? And we go all the way to negative 6, which gets a parenthesis because it's an open circle. Union, now we're going to the next part, parenthesis at negative 2 to 4 with a parenthesis. That is our answer, okay? So they don't require that you do a number line. I think doing the number line helps you write the interval, so I suggest doing a number line, okay? Let's look at the next one and just think about the way the graph would look, okay? So first, this is an x times an x times an x, which gives me x cubed, right? And we know that a cubic that's positive goes down to up, right? Down to up. Let's pull out the zeros. A negative 2, a positive 3, and a negative 8. So let's put those guys on our number line. Negative 8, negative 2, and 3. And on my number line, will those be open or closed? Open, because it's greater than, not greater than or equal to. So now let's think about that shape that we just talked about. We know it starts down, right? And all of these factors have a single multiplicity, correct? The multiplicity is 1, right? If it were 2, that would be a bounce, remember? But it's 1, so it's a cross as I do the bounce. So it must look like that. I can also test the intervals and find out that it's negative, positive, right? But why test the intervals if I understand what kind of guy this is going to be? We want greater than, so that's where it is above the x-axis, which is between negative 8 and negative 2, and to the right of 3. So my interval is negative 8 to negative 2, union 3 to infinity. That's my answer. They all get parentheses because that was just a greater than, right? If it were greater than or equal to, they'd be closed circles and they'd get a bracket. I want you to stop for a second and think about how much you've learned. All those things I just said made sense to you. Yeah. All right. Let's do another one. Okay, so do you want to test intervals or do you want to talk about the shape? Talk about the shape? Let's talk about the shape. Okay, so first thing, this guy is a positive x, negative x. So that's a negative x cubed, which means it's up to down. Right? Each of those factors has a single multiplicity, right? They're each to the first power. So that means each of those zeros is going to cross. Each of those factors has a single multiplicity. They're all to the first power. So each of those zeros will cross. If one of them had an even multiplicity, was squared or to the fourth power, that one would bounce. Okay? Let's look at what our zeros are. We have a negative 4, a negative 9, and a 5. The 5 is weird. We would have to say 5 minus x equals 0, right? So negative x is negative 5, x is 5. You can also just think of, you want that factor to turn into a 0. How do you do it? Okay, so on our number line, negative 9, negative 4, 5. Are my circles open or closed? They are all closed because this is greater than or equal to. So that means when I write my interval, they will all be brackets, right? So if we're looking at what our shape would be, it would start up over here, right, on the left, and then it crosses each of these guys. We want greater than or equal to, so we want above the x-axis. So that's to the left of negative 9 and between negative 4 and 5. So in interval notation, our lowest value is negative infinity. Remember, negative infinity always gets a parenthesis because we can't get there, right? Negative infinity to negative 9 with a bracket, union, negative 4 to 5 with a bracket. Yes, ma'am.
Remind me, how do we know if they cross or bound?
So a cross is when the power is single or odd. A bounce is when the power is even, which we're going to see on this next one. Okay. Now, testing the intervals is still an option. You can test the intervals. I feel like this is easier, right, than plugging in those numbers all the time. Okay, so here we are going to have an x squared times an x, which is an x cubed, which goes down to up. My zeros are 4 and negative 1. So I have a negative 1 and a 4. Are my circles open or closed? Closed. But notice the factor x minus 4 is to the second power, correct? Which means it has an even multiplicity. So at 4, it's going to bounce. So that means it must start down, goes up at 1, bounces at 4. We want positive, so above the x-axis, so everything to the right of 1. When I write my interval, since that 4 is already included, I don't have to break my interval up. And I just say negative 1 to infinity. Because the 4 was included. Yes?
So if it's a negative, it's not like a negative 4, we wouldn't bounce because it's negative, right?
No, we're bouncing because it's squared, because that factor is squared.
The factor.
That's why we're bouncing. Now, if this problem had been less than or equal to, X minus 4 squared times x plus 1. Oh, I just want to make it greater than 0. The difference there is that would mean the negative 1 and the 4 were not included, correct? Right? That would be the difference between what we did and what I wrote. Right? It's the same problem. I just said greater than instead of greater than or equal to. So we would still have the 4, which would bounce, and we would still have the negative 1, which would cross. But the 4 and the negative 1 are not included. So it would be negative 1 to 4 union 4 to infinity, because your number line would be negative 1, 4, and these guys would be open. Okay. I think we'll have one like that in just a second, but I wanted to be sure. Okay. All right, let's do one more, maybe two more. Okay, so we have x times x squared times x. That's x to the 4th, right? Which has a shape like a happy parabola, right? That's its end behavior. Now let's pull out our zeros. We have a 5, a 2, and a 7. That 2 is going to bounce, right? Because it has an even multiplicity, because it's squared. So on my number line, I have a 2, a 5, and a 7. Are they going to be open circles or closed? Open, 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 open. And so we know that our guy is going to start up, he's going to bounce on the 2, and then he's going to cross at the other guys. And we want less than, so we want to know when it's negative, right? And it's only negative right there in that little spot, which is from 5 to 7 with parentheses.
When it bounces,
It just bounces on the 2, like it's on a trampoline. It just jumps on the 2 and hops right back up. I want you to think about this one. What if we changed it and we said we wanted x minus 5 times x minus 2 squared times x minus 7 to be greater than 0. So it's the exact same problem, right? But I want greater than. So if you think about greater than is where it's above, right? So from negative infinity to 2, union 2 to 5, union 7 to infinity.
what?
Right? I'm just pointing that out because since that 5 is not included, we can't go from negative infinity directly to 5. Right? Because the 2 is not included. So we would have to break it if the question were greater. Since it's less, we're only concerned about the negative part, and we're okay. You gotta absorb, right?
I'm confused how we can get from infinity to 5 because it never crosses.
It touches though, and this says less than 0, not less than or equal to 0.
Oh, okay.
If it said less than or equal to 0, we could go from negative infinity to 5. right? But we can't go from negative infinity to 5 because it would just be greater. Okay, I'm just trying to point out something that I know will happen. Okay, last one. Okay, so we have x squared times x times x. So again, we have x to the fourth, which acts like a quadratic, right? Let's look at our zeros. I have a negative 6, a negative 8, and a negative 2. And the negative 6 is going to bounce, right? So on my number line, negative 8, negative 6, negative 2. And all of those circles are closed. And so we know we start up. We're going to cross at the negative 8, bounce at the negative 6, and go up through the 2, negative 2. They want to know less than, so negative, right? So all of that is negative. Big question for you. Do I need to break at negative 6?
No.
No. Good answer. Negative 8 to negative 2. I don't have to break at the negative 6 because the negative 6 is included, right? If the symbol had been less than, then I would have to break because it's equal there. Okay? How do you feel?